All right. Now, let's take a look at the example from the textbook. This is even more complicated because you are not only converting everything to the present time, it also asks you to convert everything to a future time. And it also asks you to convert everything to a new annuity, equivalent annuity. So you're gonna do, 3 different types conversions. The first is you have this cash flow, multiple cash flows on the diagram. You want to convert everything back to the present. Okay, so everything back to the present. This is annuity back to the present. Okay, that's how you find the P0. And another question is to ask you convert everything back to a future time. So annuity back to a future time. This 500 back to a future time. This 200 back to a future time. This 100, no, not back to, compounding to a future time. So it's F8. And then it asks you to do a third thing, to spread these cash flows to every year, okay, to find out the equivalent annuity. So you want to distribute this 100 to every year. Okay, every year but not the first year. Because by definition, the annuity equation can only be used when the first payment is at the end of the first year. So this is not true. Okay. And you want to distribute the 200 to every year. Okay. And the same thing, you want to distribute the 500 to every year. And you want to distribute the annuities of 400 to every year. Okay, so you see this is gonna be more complicated questions to answer. Okay, but don't worry, we have our factor method. We can do it. So now how do we do it? First, let's take a look at this cash flow. Okay, so this is not a specific problem. It's not related to any business or company or type of factory. It's just a generic cash flow diagram. So on this diagram, you have a series of year-end cash flows extending over 8 years. Okay, so you have 8 years. The amounts are 100 for the first year, 200 for the second year, 500 for the third year, 400 for each year from the 4th through the 8th. Be careful, it's not from the 1st to the 8th, okay? So be careful about that. This could represent something like the expected maintenance expenditures for a certain piece of equipment or payments into a fund. So it's just a generic situation. Note that the payments are shown at the end of each year, which is a standard assumption for this book and for economic analysis in general. So in economic analysis, we always assume that the cash flow happens at the end of every period. Okay, so the first question, question A, what is the present equivalent expenditure of all these cash flows? So find the P0. Question B, the future equivalent expenditure. So F8. 8 means it is the future value at the end of 8th year. And the question C, the annual equivalent expenditure. Okay, so of these cash flows, the annual interest rate is 20%. Okay, so now you're looking for the equivalent present value, the equivalent future value, and the equivalent annuity of these multiple cash flows. So first, let's see how do we convert all of them back to the present time. Okay, so the P0 is what? So we have, first you need to check how many types of cash flows you have. So we have this 100 at the end of the first year. We have 200 at the end of the second year. We have 500 at the end of the third year. Although there are some future values, kind of future values, but they're different amount. So you have to convert them differently, okay? So we label them as different types of cash flows. And then you have all these annuities. Okay, so this is annuity. This is some future value. You can label it as F3 because it's happening at the end of year 3. Just to make clear for yourself. And this is F2. And this is F1. Okay? So now you have how many parts? 4 parts. So same thing. You want to just write it down. So P01. The first part is from the 100. Okay? And then that is a type of future cash flow. Okay? In this diagram, because everything is going downward, so we're not going to label them negative or positive. But of course, you can do that. So everything is negative, but actually we don't have any positive ones, so we don't need to label everything. Okay? So here I don't label it as negative. But again, there are still costs. You just need to keep in mind there's no positive values to add up, so we don't have to differentiate them. So second part is from 200, and also it is a type of future cash flow. The third part is from the 500. Okay, again it's a future value. And the fourth part is from the annuity of 400, and it is annuity type of cash flow, right? Okay, so you can also label it here. The P01 is to find P given F, okay? P02 is also to find the P given F. P03 is, the problem is also to find the P given F. P04 is to find the P given A. So this is just easier for you to find out the equation and to find out the factor, okay? You can do this to the previous question as well. So now let's calculate what is P01, 02, 03, and 04. So the first part is from the 100. So the equation you're going to use is F times P given F, I% and N. And I is 20%. Okay? So now the F is 100, P/F, I is 20%. What is the N? How many periods between 0 and the time 1? Or how many times you need to jump from time 1 back to time 0? 1, right? So N is 1, okay? So here N is 1. So 100 times, what is the factor? Okay, this is the table for I equals to 20%. You're looking for P given F. So that's the column. And here, let me use this color. The N is 1. So this is your factor. Okay, so it's 0.8333. So this is 83.33. Okay? And now let's calculate the part 2 of present value. It's from 200. Still, you're using the same equation because you're looking for P given F. Same equation, but with different values. Now it's 200. 20% the same. What is the N? Between the time 2 to time 0, how many times you need to jump back? 1 and 2. So N is 2, okay? So now the N is 2. So it's 200 times, what is the factor of N is 2? Same column because you're looking for P given F, but it's gonna be the second row. So this is your factor. So it is 0.6944. So it's 138.88. Okay, what is the third part? Same equation because you're still looking for F given P. Same equation, but different values. So 500 P/F, 20%. Now what is the N? To answer this question, consider between 0 and the time 3, how many periods you're jumping. So it's 1, 3, 2. Okay? So now N is 3. So here is 3. Excuse me. So it's 500 times, what's the factor value for N is 3. So still you're looking at this column because you're looking for P given F, but N is 3. So this is your new factor. So it is 0.5787. It is 289.35. Okay, last part is P04, which is from the annuities. But be careful, this annuity begins from the end of the 4th year. So if you use the annuity equation, you only convert these annuities back to a year before when it's begin. Make sense? So by equation, the definition or the requirement of the equation, you only convert the annuity back to this time. Okay? So first you want to use the annuity equation. You are looking for some value at equivalent value at the time of 3, at the end of year 3, which is from the annuities. Okay? And that value, you can call it P3 because that's some present value compared to the later annuities. So I would say it's P3. Okay? And then once you have that P3, you can convert that P3 to P0. Okay? And the way you convert that P3 to P0 is to use that P3 as a future value and convert that future value to P0. So the first thing is you find out P3 or you convert annuity to equivalent value at the end of year 3, and that value could be called P3 because compared to the year 4 it's a previous time, so it's a P3. Okay, and then you use P3 equals to F3 because compared to the year 0, P3 actually is gonna be a value at a later time, so you can also label it as F3 compared to 0, right? And then you convert F3 to P0. So that is the 3 steps you want to calculate P0 for. This part is complicated, so pause here and re-watch this part. Why cannot we just use the annuity equation? Because if you use that equation, you are just converting the annuity back to one period in advance. Because you are starting at the year 4. So by using that equation, you only convert all the annuities back to year 3. Okay? And then you need to deal with how do you convert some value at year 3 back to year 0. That's why we have these 3 steps. Okay? So now let's do it. So first thing is you convert annuity to some present value at year 3. So that equation is to find P given A, right? So it's A times the factor P slash A I% N. And this is, we said this is P3. Also, it can be written as F3 compared to the year 0. Okay, and if you have something at a future time at year 3, how do you convert that to the present value 0? you use this value, which means you use the whole term of this time another factor, which is to find the p given some future value, right? I% and n. Okay, so this is the entire calculation. And A is 400 factor P/A. I is 20%. What is the n? Because we said by the definition of this equation, the n is gonna be how many times you jump back to the previous year, right? So for all the annuities, how many times between this one period before to the end? So it's 1 time 2, 3, 4, 5. So for this annuity problem, the n is 5. Okay, so here is 5. And another factor will help you to jump from some future value at year 3 to year 0. So what is the time? What is the n? So we already have it here. N is 3 because you're converting some value at year 3 to year 0. So n is 3. Okay. So here you want to be careful about why do we have n is 5 in the first factor for the annuity problem, and why do we have 3 here for converting a value from year 3 to year 0. Okay. This is all about the definition and how do you use the annuity equation. Okay, the annuity equation only convert the annuities back to 1 year before when it's begin. So you already have 4-year annuities, and 1 year before plus the another 4 years is gonna be 5 years, 5 periods. So this is 5. Okay. So now let's go check these factors. Let's write it down here. First factor, P/A. So same table, P/A is this column. Number of periods is 5, so that's this value. So it's 2.9900 times another one. It's P/F. And the number of year is 3. So it is this one. So 0, 57, 87. So the final is 692.26. Now you have the 4 parts of P0. Just sum them up. So P0 is P01 first part plus second part plus third part plus fourth part. And the final results is 1203.82. Okay, so the tricky part for this question for this problem is this process, okay? And how do you find out this n and how do you find out this n? Okay, so if you don't understand this, rewatch the video. And also this is an example from textbook on the page of page 133. So just go check it, okay? Make sure you understand this equation, this calculation. Okay. Then it has another question, question B, the future equivalent expenditure F8. So now the problem is much easier. You don't have to do the multiple times conversion again. Okay? You only need to, because you already have P0. So you only need to convert that to P0. Compounding that P0 to some future time to find out what is the F8, right? P0 is something you already calculated in the first question. So now it's very easy. So F8 is, the equation is to find out F given P. So it's gonna be P times a factor F slash P I% N. And the P is gonna be the P0 times F slash P 20%, because you need to compound how many times? 8 times, 8 years. So the N is 8. So P0 is what? P0 is 1203.82 times the factor is F slash P. So F slash P, that's the column, and the number of years, 8. So that's the factor. So it is 429.98. 429.98. So it's 50,176.19. So if you convert everything to the future time, the equivalent value is gonna be 5,000 something, okay? And if you distribute everything to annuities, that's gonna be the third question. So annuities is gonna be, you don't have to do the conversion of every cash flow because you already have your present value, right? You calculate it out at the first question. So you only need to distribute this present value to annuities. Okay, so to find out annuity given P, the equation is P times a factor A slash P I% N. P is P0, A slash P 20%. How many years you're gonna distribute the money? It's 8 years, so it's 8. So P0 is something you calculated out in the first question. It is 12,003.82, and the factor of A slash P A/P, that's the column. Number of years, 8. So this is your factor, 2606. So the final result is 313.73. Okay, so this is how you convert all different cash flows back to the present, compounding to the future, and then distribute them to every year. Okay, and usually we will just do the conversion just to use the multiple cash flow conversion once, and then we have one single equivalent value for all the cash flows, like this one, like we have the P0, and then we just convert the P0 to a future value or to the annuity, so that you don't have to do the conversion for every question.